Alright, since my last video, I have been asked quite a few times, so what exactly is it that you plan on doing with that chemical that you were showing in the last video? What's a hologram, so on and so forth. So I thought I'd make a video about what exactly we're doing here at SCSU. So here is the dark room that we do all of our experiments in with the holograms, excuse me. And we have a fancy schmancy little sign there, which I think is very appropriate. So let's go ahead and step on in. Now, if I take a step back here, you can see that scientists are very, very, very messy. Very messy. We don't like to clean up after ourselves. So we just work around all the trash. So, what do we start with? Let's start with the big giant laser. So over here, we have ourselves a 20 or 30, I forget. I think it's a 30 or 20. Anyway, milliwatt laser, which is a helium neon laser. I don't think I can get a very good picture. Yeah, that looks really blurry on my phone. Let's see, we have 30 milliwatt maximum at 632.8 nanometers, and this is a class 3B laser. You get this in your eye, things will not go well for you. So, what we have going on in this room is, so we have our laser, which is attached to our power source right here, and I'll go ahead and turn it on so that I can show what's going on. Okay, cool, it's on. So what'll happen is we'll turn the laser on, and that light right there signifies that everything is good to go. The light shoots out of the laser, and we have it hitting this mirror, which redirects it up towards that metallic circular looking object. And what that thing does is it helps diverge our beam so it can be spread over an area rather than in a very small focused beam like when it comes out of the tube right there. So it comes down at a 45-degree angle, and we have an illuminated little area where the laser is no longer focused but diverged. So we have things like little razors. You can see the one that says Irwin on it, a die, and some shark's teeth, which are also lined up nicely on this ruler. So what happens is we start with a very small glass plate. Let me find one, for example. We have some larger ones, but we don't typically use those. That one actually has a hologram on it already. So I'll use one of the ones that we kind of messed up on. So originally, they're not actually blue. They start out as clear. After the development, they kind of changed that color. So as you can see, there's no hologram on it. We kind of made some mistakes along the way, but you know, that's what happens. So as you can see, I'll kind of move my phone over. I have placed this glass plate up against these screws, and we might have to refocus the beam, but a large portion of the light reflects through the plate and illuminates the objects behind it. And the main point is that we want to get the information from, or the information concerning all of these objects, like what they look like, their shape, so on and so forth, to record onto the plate. And underneath these plates, I don't think it can be seen, but it's actually two plates glued together. And there's like this sticky kind of gel, which the information is recorded on. And I'll just put this down here. So what happens is we blast it with the laser, and we get actually no image at all at first. So we have to take the glass plate and bring it over to the developing area, which looks like something straight out of Breaking Bad minus meth. So we have 4 different solutions. The first orangey looking one is our developer, which is a combination of ascorbic acid and sodium hydroxide. We have a container of just plain deionized water to rinse the developer off. And the last one is a bleach solution that we made out of a few different chemicals, mainly copper sulfate, I believe. And there's bleach. And the last tray here is deionized water and a kind of wetting agent made from something called PhotoFlow. So what will happen is when we take our glass plate, when it's initially developed, it will be clear. We'll stick it in this first one here, and it'll turn black, which is actually pretty cool looking. We wash it off, then we stick it in this bleach solution until it turns clear again, and we can see it through it. Wash it off, and then we stick it in the wetting solution, and we have this handy dandy blow dryer here to help speed up the drying process. And then we get a really cool hologram. I'll show you an example of one that we made today after exposing the image for 10 minutes. So if you can see, you can almost see from this angle that there is a hologram of the razor that says Irwin, and up here near the top is one of the screws. So if I kind of move it around a little bit, you can see that it's actually three-dimensional. Let's see, what if I bring it in the light up here? That doesn't seem to work as well. Anyway, the key point with the chemical of the video that I made last time is all of these plates that we're doing, including this one, have come pre-packaged. And they've already had the sticky kind of gel that the image gets put on, which is known as the emulsion. It's already on the inside, so we haven't had to do anything crazy with it. But the new ones that we're going to have to make use different kinds of chemicals, like here's one known as ferric ammonium oxalate, and it is light sensitive, as the cover says. It's actually a really cool looking green. I'll open it up so you can take a look at it if you want to. It's actually really cool. Extremely toxic. Extremely toxic. That's the main problem with a lot of, well, not a lot, but one of the possible ways for making a hologram, which is ammonium dichromate. And the chromium is the actual hazardous portion. Another way to make one is by using ammonium ferric citrate, which is basically just a solution with iron in it. It also looks green, but hopefully we can find a way to make them less toxic, cheaper, or we will fail miserably. One of the two. So, either way, that's the plan. Oh, and I forgot to mention this table. So while making the hologram, if there is any kind of vibration going on at all, it can completely destroy the image and mess it up. So when we turn off the lights and we use the laser and expose the image, we can't talk, we can't move. The only thing you can do is breathe, and you have to be very quiet and make sure that nothing else is going to cause any kind of vibration. So occasionally we have to stick the stuff in sand so it doesn't move as much. So anyway, that is the holographic process here at St. Cloud State. So I hope you've enjoyed. Thank you for watching.